Hi guys, and welcome to 4-4 factoring ax squared plus bx plus c. Here's where things start to get a bit more challenging because we are going to be adding to the first coefficient, making it greater than 1. Last unit it was just 1, and we found it was pretty easy for the most part, but now it'll get a little more challenging. These again take a lot of practice, so don't beat yourself up if you're not getting it just yet. If it seems confusing, we will be practicing these a lot. So let's get going. These are the general guidelines, okay? We're not going to use every single one of these strategies right now, but first you always want to remove common factors. I'll show you what that looks like. In the extra notes, I'll show you what looking for a special pattern looks like, and we'll go over that in class. But for right now, we're going to be focusing on factors of AC that add to B. Factors of A times C that add to B. Okay, so here is our first example. Notice that what's different today is that this 5 is hanging out front here. It's not 1, it is 5 now. So we have A is 5. B, we have negative 17, and C is 6. Those are our A values, our B value, and our C value. Okay, the easiest way I like to do this, well, first let's look for common factors. There are none, so we don't need to worry about removing them. 2, special pattern. Again, we'll talk about that later. But 3, we want factors of A times C that add to B. So specifically, it's the A value times your C value. So 5 times 6 means we're looking for factors of 30, okay, that add to negative 17. And the way I like to do this is something called factoring trees. Christmas is coming up, so we use factoring trees. Okay, 5x squared, its factors are 5x and x. 6, listing its factors, we have numbers like 1 and 6, and 2 and 3. Okay, and the name of the game, it's basically a lot of trial and error. But as you practice more, the better you'll become. So it will take some trial and error. So we try out a path here. We're going to take, what is 5x times, we'll say 2. Well, that's 10x. And I'm going to add it to x times a 3 in this factor pair. Well, x times 3 is 3x. 10x plus 3x is not the negative 17 we're looking for. Okay, so simply put, this pair is not the one we're looking for. So you try another pair. Okay, so let's try another one. Let's try 5 times the 3. Okay, that gives me 15x. And let's try x times 2, which gives me 2x. The only little tweak is, hey, if we make both of these negative, then we get our negative 17. So again, all of the positive negatives, that all stuff comes into play. But just to be sure, again, 5x times 3 was negative 15x and times negative 3, and x times negative 2 gives you your negative 17. Now, writing this as an answer, your first factors are always going to be what's leading off, your 5x and your x. And just notice, we want 5x to go to negative 3, and we want x to go to negative 2. At this point, this is where it's very important to do step number 4, Dvorsky double check, by factoring, of course, before. Okay, again, the more you do, the better you will become. The next case, we are going to use a little more tools. So example 2, 1, it looks scary. Oh no, because of all these big numbers. Remove common factors. Okay, when we do that, okay, a common factor is 2. So we want to have left 7x squared minus 20x minus 3. Okay. Do not forget about the common factor you removed. Okay, it sticks around for the long haul. It's just simply out front. Meaning what we can do now is factor what's inside. So without talking about special cases yet, factors of a times c. So 7x and x. And then we're trying to get to negative 20. Let's try negative 3 and 1. And again, we have this 2 way out front. Okay. Well, let's think. 7x times negative 3. Hey, that's negative 21x. And x times 1 is 1x. Negative 21x plus 1x is the negative 20. So, writing everything in the end, we have that 2 that's hanging out. And what we just determined was we need 7x to go to 1. And we need x to go to negative 3. The order in which you have these does not matter. Okay, order doesn't matter. But the order in which you have the values inside does matter. So it does need to be 7x minus 3. And it does need to be, whoops, x plus 1. Okay, good stuff. Tips and tricks, we'll actually take care of those later. But before you're finished, I would like to talk about example 4 here, factoring out common terms. And these are very easy. So always want to factor out common terms first. Okay, and it's just very easy to do. So you look, what do they have in common? A 5 and a 5. Okay, so you want to bring it out front, leaving you with x squared. So it's like reverse distributing. And leaving you with 9. From here then, you can factor what's inside. And this is actually a special one here. But if you think a times c and add to b, what this ends up becoming is 5 times the quantity x plus 3, and we actually did these problems yesterday, x minus 3. So always factor out first if you can, but don't forget about it in the end. Next up here, if we remove a factor of 2 here, leaving us with 3q squared minus 7q plus 4. You can certainly use your newfound factor skills now. And we're thinking 3q and q. Factors of 4, negative 4 and negative 1 are the ones that work out for this. Again, trial and error. 3q times negative 1 is negative 3q. Q times negative 4, 4q. And those together give me my negative 7. Don't forget about the 2 out front. leaving us with 3q, which needs to go to -9, and with -4, which needs to go to q. Again, we will be practicing these if I'm going too fast. C, bring out a -5. They each have a common factor of not only 5, but -5. So you can also bring out the negative as well. And they also have a z in common. So -5z. Okay, leaving us with z minus 4. You can always distribute back to check. And you should get the same result. Lastly here, D, you're going to factor out the common factor. They all show 3 and a p. And from there, you're left with 4p squared minus 7p plus 1. And little side note, you can certainly try and factor all this. Once you do, though, again, things may be truly, your answer then would be this here. Okay, just because the inside's unfactorable, you still did all that hard work during the 3p out. Okay, special cases we will talk about tomorrow. Your essential question again is at the very top. Okay, and you really need to remember AC, add to B. We will be practicing these a lot, so thank you guys, and hopefully it helps.